Hello everyone, welcome back to my channel. Today's our topic is enzyme. So what are the enzymes? Enzymes are the organic compound or substances, okay na, which are present or produced in the living organism, okay na, the cells of living organisms. Enzymes are popularly known as the biological catalyst. Why they are called as biological catalyst? Because they involve in the metabolic activities and that is metabolic reactions, and they help in speeding up of reaction to get the product within uh, within short period of time. So for the first time, enzyme word was proposed by the scientist, that is W Kone. So he said that n means en means in, okay na, zyme means in yeast, or we can say the in living organism, okay na. So this is the history of enzyme. So this is the very important thing you must notice, that is all enzymes are proteins, but all proteins are not enzymes. So basically what it wants to explain you is that enzymes are nothing but proteins, okay na, enzymes are nothing but proteins, but all proteins are not enzyme actually, okay na, enzymes are protein but proteins are not enzyme at all, okay. This is very important. It is very much useful in examination, or we can say MCQ point of view. Next one is all the biochemical reactions are catalyzed by enzymes. So whatever the biochemical reactions, such as our metabolic activities, all reactions are called as the biochemical reactions, and that reactions are catalyzed by the enzymes, okay na. This is very important function of the enzyme, and these enzymes are the macromolecule, and their molecular weight is ranging from 10,000 to few million daltons, okay na. Enzymes, what is the function of enzyme? Basically is that it speed ups the reaction, as I've said before also, it speed ups the reaction. And Edward Buckner, he is the scientist who discovered, okay na, who discovered the zymase enzyme, okay, zymase enzyme. He is the one who discovered the zymase enzyme from the yeast, okay. Next one is we are having classification of enzymes. So basically enzymes are of two types, that is the simple enzymes, which is made up of only the proteins, okay na. As we have said that all enzymes are proteins, so see here, enzyme which is made up of proteins are called as the simple enzymes. So example of simple enzymes are trypsin, pepsin, etc. Next one is conjugated enzymes. So what are conjugated enzymes? Conjugated is nothing but the combination of something. So here combination of protein and non-protein, okay, an enzyme which is formed by the combination of protein and non-protein part is called as the conjugated enzyme. So what we call it as protein part is, we are calling the protein part of the conjugated enzyme as apoenzyme, okay. And next non-protein part is called as the prosthetic group. So this prosthetic group may be organic or inorganic. So if the prosthetic group is inorganic, then we call it as the cofactor, okay. An example of cofactors are zinc, ferrous, okay. Next one is if the prosthetic group is organic, okay now, organic components, then it is called as the coenzyme. See here, cofactor is different, coenzyme is different. So this see here, IC, that is inorganic component of the prosthetic group, then it is called as cofactor, okay, cofactor. Here if organic component is there, then it's called as the coenzyme. So CE you write here. So this is the shorts, okay, shortcut. This is IC, that is inorganic cofactor, and organic coenzyme. An example of coenzyme is NAD, FAD, etc. So complete conjugated enzyme can be represented by this. Holoenzyme is nothing but the complete conjugated enzyme, which consists of apoenzyme, that is the protein part of our enzyme, and prosthetic group is nothing but the non-protein part of the enzyme. So this is the simple classification of enzyme. So next we will see the classification of enzyme based on the IUB, that is the International Union of Biochemistry. So according to IUB, based on the reaction which enzyme will proceed, enzymes are classified into the 6 classes, okay na. So based on the reaction, type of reaction in which the enzymes participate, enzymes are classified into 6 classes. Those classes include oxidoreductases. So by the name we can understand that is oxidation and reduction are included in this. So what is meant by oxidation? Oxidation is nothing but the addition of oxygen and removal of hydrogen, whereas reduction is reverse of the oxidation, that is addition of hydrogen and reduction or uh, removal of oxygen, we can say. So these oxidoreductases are of 3 types again, okay na. This is the first type, and oxidoreductases is further divided into 3 subtypes. Those are dehydrogenases. Dehydrogenases is nothing but it is a type of enzyme that transfers the electrons. The transfer of electron is done with the help of the hydrogen atom transfer, okay na. So that's why it is called as dehydrogenases. So here transfer of electron is taking place with the help of hydrogen. Next one is oxidases. Oxidases is nothing but here the oxygen molecule is act as the hydrogen acceptor, and with the help of oxygen hydrogen is transferred from one that is substrate to the product, okay. Next one is hydroperoxidases. Hydroperoxidases is based on the substrate, that is if in substrate we are using hydroperoxidase peroxide, then we can use this type of hydroperoxidases enzyme. This is the first type, that is oxidoreductases, and the subtypes of the oxidoreductases. Next one is hydrolysis. By the name we can understand hydro is nothing but water, okay now. So here the hydrolytic cleavage, that is while we when we will add the water, then the chemical bond is break down. That's why we are calling it as the hydrolytic cleavage. So again, hydrolytic cleavage is of 3 types. Those are proteases. Proteases is nothing but it is an enzyme which breaks down the peptide bonds, okay na, peptide bonds of protein, okay na, peptide bonds of protein, and it will form the polypeptide chains. As we know that proteins are made up of polypeptide chains, so when the peptide bond is broken, then number of polypeptide bonds or chains will be formed. So this is the proteases. Next one is esterases. Esterases is nothing but the ester bond which is present in between the two esterase esters is called as the ester linkage, and breakdown of that ester linkage is nothing but the done by enzyme esterases. So example of that is nucleases. The third subtype of hydrolysis is the carboxylases. Carboxylases means, as we know that carbohydrates are linked together by the glycosidic bonds, okay. For example here polysaccharides, okay na, these bonds can be broken down or cleaved by the help of carboxylases, okay. Next, third type is transferases. By the name we can understand that is the transfer, okay, transfer of something is done. So with the help of our enzyme we can transfer the functional group. Here see this is the glucose, example is glucose. With the help glucose is converted into glucose 6-phosphate. See here no phosphate is not present in addition with glucose. Here 6-phosphate means at 6th carbon phosphate has been attacked. Where phosphate is coming from? This ATP which is converted into the ADP and inorganic phosphate. This phosphate comes and attacks here. So with the help of this we can see that the transfer of functional group is taking place in the presence of hexokinase enzyme. So this is the transferases. Next one is lysis. Lysis is nothing but the elimination of atoms, okay na, from substrate. The atom is being removed by breaking up of bonds, okay na, by the breakdown, or we can say the splitting. Here for example this is the fructose 1,6-biphosphate. In the presence of aldolase, this is the enzyme, that is lyose enzyme. With the help of this we can see that the fructose, which is 6 carbon containing compound, is broken down into the 3 carbon containing compound. We can say it as also breakdown or splitting of the substrate. See here, while the fructose is splitted down, then we can see here 3 carbon containing DHAP and 3 carbon containing G3P. So this is the lyoses. Next one is ligases. Ligases is nothing but the formation of new chemical bond, okay na. here the breakdown of bond taking place, here the formation of new bond is taking place, okay na, in between the two molecule in order to join the two molecules. See here it is quite reverse. Here we are having example of ligases is OAA, that is oxaloacetic acid. When it is combined with the acetyl coenzyme A, here the new bond is formed, and it will be converted into the citric acid, which is the which is the combination of oxaloacetic acid and acetyl coenzyme A. It is done with the activity of citrate synthetase enzyme. So ligases is nothing but helpful in joining. Okay, next one, last one is isomerases. Isomerases is, as we know that each and every component is having their isomers, that is identical or mirror images of each other. So that identical, that is by the rearrangement of substrate, one molecule, that is one isomer of a substrate is converted into the another isomer by the rearrangement of the substrate. Okay, for example, here ribulose 5-phosphate is converted into the ribose 5-phosphate. How? With the enzyme isomerase. That is, it is nothing but they'll go under some rearrangement of that component, and they'll form the mirror images. This is the thing. So I hope you understand this, and please hit like if you like the video, subscribe to my channel, and please support me. Thank you for watching my video.